Okay, so in this video we are going to be doing homework 7.2, question number 3. We're asked to multiply or divide as indicated. This is multiplication. And then be sure to reduce all answers to lowest terms. What that means is we're going to multiply fractions straight across, and the reducing means we're going to acknowledge all those secret times ones. I want to do this problem on a separate piece of paper. And here it is. Now, when we multiply fractions straight across, really what that amounts to is just making a nice long division bar and putting parentheses around any expression that has more than one term. And we can go ahead and do that right away and then factor each of those pieces. I think visually it'll look nicer if we kind of compartmentalize our thinking and do all the factoring first and then multiply straight across. So I'm giving myself permission to just think about yellow right now and factor it. Why am I wanting everything factored? I'm wanting everything factored so I can acknowledge secret times 1. And I wrote times 1, right? So if I just look at yellow, let's practice factoring yellow. There's a GCF of 3a. 3a times a will give me 3a squared, and 3a times a positive 2 will give me 6a. So yellow is yellow. Now the denominator fraction here is a difference of perfect squares. A squared is a perfect square. It factors into a times a, gives me a squared. And 9 is also a perfect square. It's 3 squared. And one of these is negative and the other is positive. It doesn't matter which one you do because order does not matter in multiplication. Object times object. If you are rusty on that difference of perfect squares factoring pattern, I want you to go ahead and multiply this out and see that when you combine like terms, you do end up with a squared minus 9. Now here, a squared minus 3a, the GCF there is a times a gives me a squared, and a times a minus 3 gives me minus 3a. Orange is equal to orange. And the denominator, 3a, is already factored, right? It's a 3 times an a if you want. I think I'll just write it as 3a. Now I'm going to go ahead, we can write that we just factored here. Now I'm going to go ahead and multiply straight across. 3a times a plus 2, there's yellow, times orange, times a. And you don't have to write these dots, but I'm just emphasizing the multiplication. So I've got yellow times orange all over green times my 3a. Here we multiplied straight across. All right, now you are free to go ahead and start acknowledging your secret times ones. I'm going to go ahead, since order doesn't matter in multiplication, I'm going to write it in a different order just to see those secret times ones better. This is optional. But you want to really make sure that you don't get in the habit of just saying, hey, I see a similar looking thing on the bottom and the top, they go away. Because if this wasn't all multiplication, if there was a minus or a plus sign in here, you would not be able to do that. Okay, So we've got, what are my common factors? My numerator has a times 3a, and so does my denominator. My numerator also has a times a minus 3, and so does my denominator. So order doesn't matter in multiplication. 3a times a plus 2 times a minus 3. Denominator has a 3a factor. It has a times 3a. It also has a times a minus 3, and then a times an a plus 3. Here are my little secret times 1s, and when I multiply by 1, that doesn't change anything, which is why I'm telling the reader I can get rid of them. And this is exactly like simplifying fractions. Here I'm simultaneously multiplying and dividing by 7. No change there, right? It's the exact same concept. It just looks a little bit more overwhelming because there's letters and more numbers there. And here I am, done. What's left in the numerator is a times a plus 2, and what's left in the denominator is a plus 3. Now the computer will accept this answer. You also could multiply out the numerator. A times a is a squared. A times positive 2 is plus 2a. And the calculator, your computer, will accept this answer as well because they're equivalent. This is done too. So let's go ahead and practice entering those answers into our computer. Okay, so again, I'm going to use this little yellow arrow to get my fraction. Coming up into the numerator, my numerator is a times, the second I hit parentheses, it inserts 2 parentheses for me, which is helpful. Coming back inside there, I want to write an a plus 2. Down in the denominator, I want an a plus 3. I'm going to hit save. My computer can read it, the syntax is okay, and that's exactly what I want to see. So when I hit submit, let's see how I do. We did great. And again, if I wasn't using that little yellow arrow, how they're showing it right there is how you would need to type it. They're using parentheses to help you see the entire numerator and the entire denominator. Let's do this again and show that if we multiply out that numerator, we're fine. Here, I hit my fraction. Coming up in my numerator I want a squared. I'm going to hit a, and this x with a little box up high is inserting a field up high where I want my exponent. So when I hit that, notice the little gray popped up high up there. That allows me to put in a 2 for my exponent. Now, I don't want to hit plus right away because do you see how I'm still on the same line as the exponent? I want to go ahead and move my cursor over. Now it dropped down that level. That's where I want my plus sign. Plus 2a. And in my denominator, I want a plus 3. Save. The computer can read it, and that's exactly what I want to see when I hit submit. Perfect. We did a great job. Okay, so this problem is done. At this time, I want to actually make a note for you guys about domain restrictions. This is optional, but it becomes important in future math classes, so I feel like just making a note on these 2 problems. So we have gotten them correct. But remember in section 7.1, you were finding the x values, the variable values that weren't allowed. We're not allowed to divide by 0. So on this problem, problem number 1, notice right here, x cannot be minus 3, because minus 3 plus 3 is 0. I'd have a 0 in the denominator. And that is clear right there. X cannot be minus 3. But notice when I removed this factor because of the secret times 1, x still can't be positive 3. Positive 3 minus 3 is 0, right? And when I remove this factor, it's not obvious anymore when I'm looking at this expression that x is not supposed to be equal to 3 either. So really I should be doing a little note to my reader to say that x cannot be positive 3. And this is optional. It's a subtlety that's important for future classes, right? So for an example, in the example 2 here, a can't be 0 because 3 times 0 is 0 times who cares what is 0. And it's not clear to me when I'm looking at the answer here that a can't be 0, so I should do a little note to my reader. A can't be 0. Also, we removed this factor when we acknowledged this times 1, right? So here, a can't be positive 3. A cannot be positive 3. This one, a not being equal to negative 3, that's still apparent to me when I'm looking here at my answer, because if a was minus 3, I'd have a 0 in the denominator, so I don't need to make a note to the reader there. Okay, again, this is just a subtlety to incorporate some of the stuff from 7.1 about domain restrictions that's important for future classes. If it's a little overwhelming, just don't worry about it right now, okay? Excellent. I hope this video was helpful.